Right, any problem. So now we're given a demand function and a supply function. Price is in dollars, quantity in thousand. All right. Supply and demand. If there is 6 per unit negative externality that is associated with the production of widgets, what is the socially optimal quantity? All right. So if you have a regular supply and demand, and you have a negative externality, right? How do you fix it? How do you fix a negative externality? What does the government need to do?
Subsidize.
Negative externality. Tax. Right. When they tax, what happens to the supply curve? Shifts to the higher by what? By how much? The amount of the externality, $6. So basically the difference here between those two, the vertical difference is going to be $6. Right? So the social supply curve needs to be with the same slope, but with a $6 higher with 6 higher intercept. Right? So let's make that here. The supply curve, the social supply curve, right, is going to be, well, 8 is the intercept, but it needs to be higher by 6, right? So this is 14 plus 0.5 quantity supply. My demand curve stays the same. So basically the interaction between the social supply and the demand curve is where my optimal quantity is going to be. Right? We'll just set them equal to each other. So when they intersect, sorry, this is 40. When they intersect, the prices are going to be the same and the quantities are going to be the same. So I have 41 minus 1.5 Q. I can name this Q star equals 14 plus 0.5 Q star. The Q's go to one side. So 40 minus 14, this is 26. Equals, what is it, 2Q? Is it, oh, right. So Q star is 13. And this is the socially optimal one. Right, so if the government imposes a tax, fixes the externality problem, then the quantity supply is going to be 13 units. Right. So again, with the same demand and supply curves, if the world price is 10, what are the gains from trade to a country with the domestic supply and demand equations represented in this scenario? All right. So let's create a picture. All right. So we have some supply and demand in this country. This is supply. This is demand. Right. There's no externality here. That was for the previous problem. So here we're looking at the original curves. 10. What are the gains from trade to a country with the domestic supply and demand equations? All right. So gains from trade. We actually derived the formula for that, if you remember. Right, so this would be basically the difference in total surplus with and without trade. And whether it's above or below doesn't really matter, right? The formula stayed the same. Basically, the gains from trade would be, in the case of imports, it would be the area of that triangle, and in the case of exports, it would be the area of that triangle. You remember that? Okay. So the area of that triangle, right, this would be the base of those triangles would be basically the difference between quantity demanded and quantity supplied at the world price, right? And the height of this triangle would be the difference between the domestic equilibrium price and the world price. And if you put everything in absolute values, then you don't have to worry about whether it's below or above. So the gains from trade they're going to be the absolute value of the difference between the demand, the quantity demanded at the world price minus the quantity supplied at the world price, right, in absolute value, which will be either the amount exported or the amount imported, depending on what the world price is. Times the absolute value of the difference between the world price and the domestic equilibrium price. This whole thing divided by 2, this is a triangle. Right. So given that formula, what I need to know is, well, first of all, the world price, and I'm given that, it's 10. I need to know the equilibrium domestic price, so with no trade. I don't know that, but I can find it by just looking at the two equations, setting them equal to each other, and then I'll find the domestic price. And then I also need to find the quantity demanded at the world price and the quantity supplied at the world price, which I can do with the two equations that I have. So if the world price is 10, I would set this equal to 10, solve for quantity demanded, then set this equal to 10, solve for quantity supplied. Right? That's the plan. And I'm just doing some math, basically. So let's start somewhere. Quantity demanded at $10, right? At a price of $10. So I set the price to 10, and I have 40 minus 1.5 quantity demanded. Right, so 1.5 quantity demanded equals 30. So the quantity demanded at a price of 10 is 20. I'll do the same for the quantity supplied. Right. Quantity supplied at $10. This is 10 equals 8 plus 0.5 quantity supplied. What is it? 2, 4, right? 2 equals 0.5 quantity supplied. Quantity supplied equals 4. Right? So basically, the difference between quantity demand and quantity supplied is going to be 16. I know the world price, so the only thing I need to figure out now is the domestic price in equilibrium. So I would set the two equal to each other. That's where the two curves are going to intersect. So for Q, once I have Q, I can plug it back into either of the functions to find the domestic price. Agreed? Right. So 40 minus 1.5 Q. I'll call this QD star equals 8 plus 0.5 domestic star 32 equals 2 QD star, or the domestic quantity that will be provided with no trade is 16. Now I get that 16, I can plug it in either equation. Let's plug it in the supply curve. 8 plus 1/2 is 16 is 8 plus 8, which is 16. So the domestic price in equilibrium is $16. Okay, now I know pretty much everything. So I can just plug it in. And my gains from trade would be, well, the difference between quantity supplied and quantity demanded. First of all, do we have imports or do we have exports? Imports, right? Because the equilibrium price is 16, this is below. The world price is 10, so it's below that. So we have imports in the amount of 16 units. So I have 16 times, and then the difference between the world price and the domestic price domestic is 16, world is 10, so it's in absolute value it's 6, right? Divided by 2, 48. And this is in thousand.